Create a new file. Switch to Assembly4. Create assembly file. Create new body under parts. Create a new sketch. Use default LCS. Draw two construction lines. (40° from x-axis). Draw two arcs. (80 mm). (78 mm). Revolution symmetric 5 degrees. Create a new sketch on YC plane. Draw two circles. (2 mm). And 1.4 to represent a drawing at the center. Change C to 40. Reverse. Pocket at 0.5 mm. The out reverse. Create a datum pane. Select YC pane face. Change the axis to Y and rotate it 36 degrees. Select the plane and create a new drawing. Draw a circle 2 mm. Change C to 40. Pocket it 0.5 mm. So the origin, select pocket, select mirror, select reference, change the color to amber, switch to wireframe, apply fillet to corners, switch back to as is. Switch to Assembly4. Create new LCS. Select a circle, concentric. Duplicate the body. Move the body to parts container. Rename the body. Delete revolution and pockets. When I change the drawing, the revolution may break. I will keep the sketch and the data pane. Change 80 to 76. Switch to Parts Design. Revolution 5 degrees symmetric. Change the pane to 37. Pocket it. Reverse 1.5 mm. Edit the pocket, select reverse. Change C to 37. Pocket it. Reverse 1.5 mm. So the origin, select pocket and mirror. Select reference. Switch to wireframe. Apply fillet to corners. Switch back to as is. Go to Assembly4. Create new LCS. Select the circle, concentric, hide the bar. Create a new body. Create a new sketch. Use default LCS. Draw a circle. 3 mm. Change C to 4. Pocket it. 34 mm. Create a new drawing on YC pane. Draw a circle 10 mm. Symmetric 8 mm. Select the face, create a new sketch. Draw a circle 3.2 mm. Pocket it, full O. Create a new drawing on XZ pane. Draw a rectangle. Four mm. Make it symmetric. Mm. Pocket full O. Symmetric. Go back to Assembly4. Create new LCS. Select the center circle, concentric. Switch to Parts Design. Apply fillet to edge. Change the color to blue. back to Assembly4. Create a new body. Create a new sketch. Use default LCS. Draw a circle. 3 mm. Pad it 30 mm. Create a new sketch on XC plane. Draw a circle. 3 mm. Pad it 38 mm. Edit the pad. Make it 2 dimensions. Other end is 6 mm. Apply fillet to the top. Change the color to light blue. Create a new sketch under Assembly. Use default LCS. Draw a horizontal line. .39 mm. Create LCS. Select the line. Change the point size to 15 so it's easier to select the vertex. Select the line. C tangent to edge. Select the vertex. Flip the axis. Add variables. Distance, height, radius, as angle. Spacing. Change the color to green. Hide the bar. Insert the outer bar. Attach to the line of parent assembly. Move C by 1 mm. inserted in the bar. Attach it to the outer bar or to the line of the parent assembly. It is the same. Change Z to -2. Select the outer bar and the vertical axis by holding the Control key and then select Polar Array. The default count is 6. Select the inside bar, the vertical axis, and Polar Array. So the bars are 60 degrees apart. Just change it to a different angle, say 20 degrees. Change the angle of the bar to any angle, say 30 degrees. For the interbar, it will be -30 degrees. The next step is to set up relationship between these bars so they can join properly. The center of the upper joint is set at 36 degrees. So the vertical distance is 22.92 mm from the center to the joint. When the bar inclines at certain angle, the distance and height can be calculated by sine and cosine. These are not the distance along the curved bar. They are projected distance on a paint surface. When the angle is 52 degrees, the distance is 18 and the height is 13. The radius to the center of the bar is 39 mm. Together with the height, I can calculate the radius from the center to the joint at the top. Then the angle for spacing can be determined by the distance and the radius. From this example, the angle for spacing is 60 degrees when the bar inclines at 52 degrees. So put 52.65 degrees here. For the interbar, it is -52.65. For the spacing, put 60 degrees. Now all the bars join properly. Enter the formula into the variables. All other variables are calculated based on S angle. So put 52.65 for the S angle. The calculated angle is 30 degrees, so the spacing is 60 degrees. Put the variable at the spacing. For the bar, just put variables .s angle. This one would be minus variable .s angle. Run the animation. Start with a range from 12 to 52. So the spherical scissor is running properly. All the joints are okay. Change the count to 8. The formula is good for different number of counts. The maximum range of S angle is about 34, as the maximum spacing for a set of bars is 45 degrees. So it looks good. Insert the center support. To the origin. This is good. Insert the center wall. Lower it by 4 mm. I cannot attach the center rod to the bar, as the bar are repeated 8 times. I will set up a formula to rotate the rod at the same speed as the bar. When S angle is 5, the spacing is 3.62. So the initial position is at 50.68 degrees. The conditional expressions is like this. The speed is 7 times of the bars, because their 7 bars are moving together. initial position is good. So run the animation. Hide the master sketch. Hide the LCS. Run the animation again. If you find this video interesting, please subscribe and give it a like. Thank you for watching.